Get back with Chapter 9, Lecture 1. So we're talking about an expansionary fiscal policy. This is when we have a recession is our problem. And a recession is when the full employment income is greater than equilibrium. So we are stuck at equilibrium at a position less than full employment. We want to get more income. We want to increase income. To do that, we got to increase aggregate expenditures. If we increase aggregate expenditures, we will increase income. I guess cause and effect will go this way. And how do we get aggregate expenditures to increase? Well, we can use fiscal policy. We can increase government spending directly, G. And or we can cut taxes, T. And that will be our expansionary fiscal policy to fight recession. And if inflation is your problem, inflation becomes a problem when our equilibrium income is now above full employment. We're trying to buy this amount of goods, which is more than we can produce. This is the limit. This is our production possibilities frontier. This is outside the frontier. We're trying to buy a combination of goods outside the frontier. That is not possible. That would just translate into higher prices. So we want to counteract that inflationary situation by running a restrictive fiscal policy. So now our goal is to get aggregate expenditures down so we can drive down equilibrium income, get us toward equilibrium at full employment. So we can do that by lowering government spending directly and or indirectly by increasing taxes. So let's go back to our table. And what I did is I made a clean version. Instead of having my messy writing, I typed the numbers in. These are all the same numbers we had in this table. So now let's say on the exam you do all this work and you solve for equilibrium at 5,000, which is correct. And so again, equilibrium income is $5,000 billion. And now I tell you where full employment is. I tell you now it's $7,000 billion. That's FYF. And so now we are at equilibrium at less than full employment. So we have a recessionary problem here because this number, equilibrium, is less than full employment. $5,000 billion is less than $7,000 billion. So using fiscal policy, we can attack that problem in one of two ways. One is through government spending. Another way is through taxes. If we use government spending, we're going to be using the spending multiplier equation for fiscal policy. And that's right here. A change in y, we want to get y up in this case, increase it, is equal to the spending multiplier times the initial change in government spending. That's our fiscal policy right there, change in government spending. What number of change in government spending will get us to equilibrium at full employment? So we want this. This is not the $7,000 billion of full employment. This is the change. This is the difference between where we are and where we want to be. What number is that? $2,000 billion, right? We're at equilibrium at 5,000. We want to be at 7,000. So this number we want to have at $2,000 billion. And we want that to be an increase, a positive number. We need our spending multiplier. That's right here. And that would be 1 over 1 minus the MPC, which is 1 over 1 minus 0.75y, which is 1 over 0.25. And 25 cents goes into $1 4 times. I like to divide by decimals thinking of money. A lot of students don't think they can divide by decimals, fractions, but you do it all the time whenever you make change. And so that will be 4. And so the question is, what would be the initial change in government spending? That's the unknown. That's that right there. Now it's a simple algebra problem. What times, or what multiplied by 4 gives us 2,000? If you can't see it, just take out your calculator. What we want to do is this is the unknown, we could divide both sides by 4. And so the question is 2,000 divided by 4 is what? The answer is 500. So we want government spending, G, to increase by $500 billion. I don't even have to go back to the table and plug everything back in again with a new number for G. I could do that, but I don't even need to do that. This equation will work. And if you want to confirm that and go back to the table and just replace all these numbers by 1,750, which is $500 billion more than before, do all the number crunching again, you're going to end up with that number right there being 7,000. In fact, if you think about it, if I just increase that by 500, it would be the 7,000. And that's sort of I don't know, I wouldn't say cheating way of doing it, but that's a quick way of doing it. And so that'll be a question on the next quiz right here. You should expect a fair amount of them. I'll probably give you maybe in the multiple choice part, maybe 3, 4, 5, like that. We could also use taxes as well. So it's also a tax multiplier. Now taxes don't work the same way as government spending. If we increase government spending by $500 billion, that's not going to increase consumption. I'm sorry, that's not going to work the same way as taxes. If we cut taxes by the same $500 billion, that's not going to increase consumption by the same amount. If taxes are cut, we're going to put some of that money where? In savings, because this will increase our disposable income, right? And so we're going to take a portion of the $500 billion tax cut and put some of that into our savings. So dollar for dollar, we're not going to get the same spending impact if we cut taxes by the same amount. If we're going to use a tax policy, we have to, what's the term? We have to, I don't know, just drew a blank. We have to energize it. I don't know. Throw in a bit more money there. And so we have to make the tax cut not just $500 billion, but we have to bring it up a bit more. Now, without going into a long proof, I can just show you the tax multiplier is right here. Your book uses it as a negative MPC over MPS. That's fine. I think of it this way. It's really simple. It's 1 minus the spending multiplier. I don't have to remember this equation here. I just know it's 1 minus the spending multiplier. And so the spending multiplier was 4, right? On the other side, over here. So what's 1 minus 4? Negative 3. Yes, the tax multiplier is a negative number. It works the opposite. Higher taxes lowers aggregate expenditure. And so if you raise taxes, that's going to have a negative effect on spending. If you cut taxes, that will have a positive effect. If you cut taxes, that'll be a negative number, but a negative times a negative would be a positive increase in aggregate expenditures. So the spending multiplier is a positive number and the tax multiplier is a negative number. Also, your book makes a distinction between the investment multiplier and the government spending multiplier. I don't know why they do that. It's the same. It's 1 over 1 minus the MPC. It doesn't matter if the money comes from business for investment or government spending G. Money is money. Again, we don't differentiate where it comes from when we receive it. It's all the same. All gets put in the same cash register. So now we have a very similar tax multiplier equation. That's again that's our policy goal. We still want to increase income by $2,000 billion. Our tax multiplier is negative 3. I'll put parentheses around it because it's negative. I guess it looks, I don't know if people do that. And they want to times that by the initial change in taxes. That's the unknown. So do the same thing. Divide both sides by negative 3. So we take $2,000 billion. Remember, we want to increase income by $2,000 billion. Divide that by -3, and that'd be -666. Rounded up to -667. So we need to cut taxes by $667 billion. Times that by 3, you will get the $2,000 billion increase. Remember, it'd be a negative $667 billion times a -3, and that'll give us $2,000 billion. Do another problem for the exam down here. And let me just stop there and come back for another part. We're almost done with this lecture.